Hello everyone. So we are gonna have some problems about the radicals, and we're gonna try using the square root binomials. Okay. So the first question is a national sprint round number 10, and one of the oldest problems. So we want to write this expression as difference of square roots of two integers. So I'll use two different approaches, but I'm gonna try using the second approach mostly. So we are like given the 5 minus 2 root 6, and then this is under also another radical. Sometimes we call this a nested radical, and we are told this is equal to the square root of two integers. So let's say square root of a minus square root of b. And this is what we are told, and we like to write this guy in this form, okay? So since there is a radical and then there is another radical, which is not nicer, so I'm gonna take the square of both sides so we can actually get a bit better expression. The square root of square will be just the number inside of the square root if this guy itself is a like positive, so which is like 5 minus 2 root 6, right? And the right side, you can expand the right side by using square root binomial, which is like, I just want to remind. So if I have a plus b given minus, if I have the square of this is equal to square of the first term plus or minus 2 times the first term times second term plus the square of the second term. And this is our square root binomial important identity. And if I apply this in our right side, so square root of a, just a. And since there's a minus, that will be negative. So minus 2 times this times this. So that will give us 2 times root a times root b. So this is equal to the left side, right? Since like we can combine these two radicals together. So let's do that. So 5 minus 2 root 6 equals a minus 2 root ab. So since we have two expression or two numbers are equal to each other, and the left side have a rational part of 5, and the right side has rational part of a, so they has to be each equal to each other, which is why a is 5, and then negative 2 root 6 is the irrational part, and negative 2 root times ab is also irrational part. So the inside of the radical is 6, inside of the radical is ab. So then I will just go with a times b is equal to 6. But I do know a is 5, right? So let me double check. So this was 5 minus 2 root 6. And then we got, oh, actually we have something else as well. So plus the square of this guy, which is just b. So then if I want to add this right here, so then the things will change. So then we have a and b are as two like rational parts. So that is going to give us a plus b is equal to 5. And since we are negative 2 right here, negative 2 right here, they are the same. So the number inside of the radical is 6. This is ab. So we do have a times b is equal to 6. And then this is going to be a guide for us to use actually as a second approach. So we have the product is 5, and product is 6, and the sum is 5. And you can solve that equation by substitution or some other ways. But since we know a and b are integers, so we can just go ahead and see that that's 3 and 2 that works for this case. So I can just choose a is 3 and b as 2. I can do it the other way around, but since this is root a minus root b, I like to make this to be largest, because otherwise in some cases we cannot really define the difference when you take the square root. So which is why we just need to choose this guy to be larger than the other way, so which is 3 and 2, and that is going to be our answer. So that this expression can be written as square root of 3 minus square root of 2, and that is my final answer. But the question is, like, should we do this much for, right? I would say no, because we have something nicer now going on. So instead of just going like saying this expression is equal to this guy, we actually gonna try to make this inside a perfect square by using square root binomial. So how this is gonna look like? Like remember the sum of two numbers was 5, and then the product was 6, which looks like we have two numbers right here, 5. I mean, the sum is 5 right here, and the product is right here. And then this 2 was in the in front of the radical. So maybe there is something we can do it differently. So what I'm gonna try, I'm gonna make this guy as square root binomial. So, and this could be written as like 5 and like 3 and 2. So I'm gonna write it 3 minus 2 root 6 and then plus 2. You will see in a second why I'm doing this way. And right now, this is a integer, but I can write this 3 as square root of 3 to the second power, and then this is going to be minus 2, and then 6 can be written as root 3 times root 2, and then this can be written as root 2 to the second power. And now this is exactly in this form, which is a square of binomial, right? So then I can just write this as square root of 3 minus square root of 2 to the second power. And then this was on the radical already. And then these guys will cancel each other. So you will get root 3 minus root 2. And this is the same thing. But, you know, it looks like the same thing we just did it, but we just approach slightly differently. So as of now, instead of doing this one or doing this one, we are going to ask ourselves, like, if we have a 2 right here, which is plus or minus 2, we can try to make this square root binomial, because in square root binomial, we have 2 right here. And if there is a 2 right here, then you just want to ask yourself what two numbers I should multiply to get the number in radical, and what two same numbers should I add to get this number. So if there is two things like that, two integers like that, we can actually complete a square by this square root binomial, and then we can simplify this immediately. So I hope that is clear. So let's use this in some other questions, okay? So let's look at the second question. So here's the second problem. So we have now 17 root 12 times root 2. So the same question, just a bit wordy, but I'm going to use the result of the previous problem. So like this number was 2 in the previous problem, now it's not. So I'm going to go ahead and write this guy as 2 times 6, right? And then I can just pull that 6 inside of the radical, which would be 6 squared times 2. Okay, and then this guy now is 17 plus 2 times 72. And if you remember the previous problem, we were trying to see what two numbers I should multiply to get this number, what two numbers should I add to get 17. So it looks like we have 9 and 8, so that's just the product is 72. And then this is going to be 9 plus 8 to get 17, right? So if that's the case, then we can just make this guy equal to like 9, like square root of 9 plus square root of 8 to the second power. If you don't see it, let me just do this one more time. But from going forward, we are not going to do that much work. So if I want to write this as like 9 plus 2 root 72 plus 8, right? And then this is going to be equal to 3 to the second power. And then this is going to be 2 times 9 times 8. I can just write it root 9 times root 8. And then this is going to be root 8 to the second power. So just imagine A is 3, B is root 8. And then this is going to be square of that like binomial. So I can just rewrite this guy as square root of 9, right? Because this is like 3 squared, which is 9. So the square root of that will be like square of this will be just 9. And then plus root 8 to the second power. And then if I take the square root, so these will just eliminate each other. So you should get just 3 plus 2 root 2. And we got the answer, okay? So again, without really doing this process, like here's what I will try to do so as we go. So it's 17 plus 2 root 72, right? As soon as we got this, as soon as we make this number 2, then we just like saw that this is 9 times, 9 plus 8. And then this was 9 times 8. Then you're going to just make the largest 9, the square root of 9, plus square root of 8. And then you can immediately say this is going to be the case. And that's just the 3 plus 2 root 2. And we are done. Okay. So let's try another one. The number 3 is AMC10 problem. This was number 16. So I'm gonna just use the feature. So this is not 2 again, so I'm gonna make that 2. So 9 plus, this can be written as 2 times 3. So if I put this 3 inside, that will be 3 squared times 2, which is just 18. And that is the same as what we are given, plus, and then the same idea, so 9 plus, minus 2 root 18. Okay, and since this is 6 times 3, this is 6 plus 3, so that means this guy could be written root 6 plus root 3. Okay, and then this could be written as root 6 minus root 3, so these will cancel each other, so we are gonna end up getting 2 root 6, and we are done. As you see, this is a number like 16, so, but as you like see, this is not really that challenging after, especially seeing that square of binomial is useful. So let's do one more. The last problem for now is the number 28 on a sprint run. And we have same idea. So I hope you can do this question now easily. So let's try again. So 15 minus, so this is 6. I'm gonna make it 2. And this is going to be 3 goes inside our radical, which is 3 squared times like 6, which is 54. And that is going to be on the radical. And then we do have 15 plus 2 root 54. Okay, and then that is going to be on the radical as well. So I'd like to ask now, what two numbers should I multiply to get 54 and add to get 15? So that's 9 and 6. So then the first one is going to be root 9 minus root 6, because this is a minus. And the same idea, this is going to be root 9 plus root 6. Okay, so these will be canceling each other. So this is 3 plus 3, which is just 6, and we are done with the problem. So as you see, it's a number 28 on a national test, but this is what we just need to do. But if you do know this background, the question is very simple. But if you don't, then we should still try our first approach that we actually try. So that might be useful as well, okay? So I'll see you in the next video.